Hey everyone, welcome to another deep dive. Today we're tackling secure coding. Let's face it, prepping for the CCSP exam can feel kind of overwhelming.
Right. Oh, absolutely. There's a lot to cover.
But the cool thing is, a lot of these concepts, they're not just theoretical, they're practical skills that'll make you a better developer.
For sure. And it's not just about passing an exam. It's about building that security mindset from the ground up.
Right, it's about building that fortress. So let's start with the foundation. What are some of the most common security risks developers need to be aware of when they're building applications? What are the attackers actually trying to exploit?
Well, one of the biggest ones is input validation, or rather the lack of it.
Okay, input validation. That
Uh,
sounds familiar.
Yeah.
But remind me, why is it such a big deal?
Think of it this way. Every time you have a form on your website or you're taking in data from somewhere, there's a potential entry point for attackers.
Ah, I see. So if you're not careful, they could slip in some malicious code.
Exactly. And that code could do anything from stealing data to taking control of your entire system.
Yikes, that's scary. So how do we stop them?
That's where input validation comes in. It's about making sure that the data you're receiving is what you expect it to be. You're checking it at the door, so to speak.
So it's kind of like a bouncer at a club, only letting the right stuff in.
Exactly. And there are a couple of ways to do it. You've got whitelisting.
Oh, whitelisting. So that's like a VIP list, right?
Yeah, you're basically saying only these specific values are allowed.
So if you are asking for someone's age, you might whitelist only numbers between 18 and 120, for example.
Yep, that's a good example.
Yeah.
It's very secure, but it can be a bit rigid, especially for complex data types.
Right, like if you were asking for someone's job title, it'd be tough to whitelist every possible job title out there.
Exactly. And that's where blacklisting comes in.
So instead of defining what's allowed, you're defining what's not allowed.
You got it. You're basically saying block anything that looks suspicious, like certain special characters or HTML tags that could be used for cross-site scripting.
That makes sense. But it also seems like it could be trickier to get right.
Yeah.
You have to anticipate every possible bad thing.
You're absolutely right. Blacklisting is more flexible, but it also requires more vigilance.
Okay, so we've got whitelisting and blacklisting. Now, where should this validation happen? On the client side, like in the user's web browser, or on the server side?
That's a great question, and it's one that often trips people up on the CCSP exam. Client-side validation can improve the user experience, but it's not enough on its own.
Why not?
Because a determined attacker can bypass client-side validation. They can manipulate the code in their browser to send whatever data they want to the server.
That makes sense. So server-side validation is a must.
Absolutely. It's happening on your systems where you have more control.
So it's like having that security guard at the main gate, no matter what other security measures you have in place at individual buildings?
That's a great analogy. You want multiple layers of defense, and server-side validation is a crucial one.
Okay, so we've got input validation covered. What other major threats do developers need to be aware of, especially those studying for the CCSP?
Well, another big one is SQL injection.
SQL injection, that sounds scary. What exactly is it?
Imagine a hacker trying to sneak malicious code into a database query. This can let them do all sorts of nasty things, like stealing data, modifying data, or even taking control of the entire database.
That's terrifying. So how do we protect against this? Is there any way to stop this from happening?
One of the best defenses is using parameterized queries.
Parameterized queries. Okay, break that down for me. What does that even mean?
It's all about separating the data from the commands in a database query.
I'm still a bit fuzzy on how that works. Can you give me an example?
Sure. Let's say you have a login form where users enter their username and password. With a traditional query, you might just plug those values directly into the SQL code.
Oh, I see. And that's where the problem lies, right?
Exactly. Because an attacker could enter malicious input that changes the meaning of the query.
So, they could enter some special character that turns a simple login request into a command to delete the entire database.
That's the idea. But with parameterized queries, you create placeholders for the user input, and the database treats those inputs as data, not as executable code.
So it's like using those fill-in-the-blanks instead of letting someone write whatever they want.
That's a great way to put it. And stored procedures are a common way to implement parameterized queries. They're pre-compiled sets of SQL code that can be called with specific parameters, which further enhances security.
And if I remember correctly, stored procedures can also improve database performance as well.
You're right. They're often cached on the database server, so they execute faster than dynamic queries. So it's a win-win for security and efficiency.
I like win-wins. Okay, so we've got input validation and parameterized queries as two of our main defenses. What other essential elements should we be thinking about when building this secure coding fortress?
Well, next up, we've got authentication and session management. These are all about making sure that the right people have the right access and that their sessions are secure.
Okay, authentication. I mean, that's how websites know it's really me logging in,
Yeah.
right? Not some imposter.
Precisely. And it all starts with strong password practices. Things like never storing passwords in plain text.
Oh, yeah, that's like Security 101, right?
Absolutely. But there's more to it than just choosing a strong password. We also need to protect those passwords when they're stored and when they're being transmitted over the network.
Okay, so how do we do that?
Well, when it comes to storing passwords, we use techniques like hashing and salting.
Hashing and salting, those sound like something you'd do in the kitchen.
Mhm.
But I guess in this case, it's about protecting our data.
Exactly. Hashing transforms a password into a unique string of characters, making it virtually impossible to reverse engineer. And salting adds an extra layer of randomness, making it even harder to crack.
So even if someone manages to steal the hashed passwords, they can't easily figure out the original passwords.
Right. And when it comes to protecting passwords in transit, we use encryption protocols like TLS and HTTPS. These create a secure tunnel between the user's browser and the server, preventing eavesdroppers from intercepting sensitive information.
So it's like putting those passwords in an armored car as they travel across the internet.
Exactly. And then there's session management, which is all about controlling how long a user session remains active and what they can do during that session.
Right, because even if someone has a strong password, if their session is hijacked, an attacker could still gain access.
Exactly. Think of it like this. Even if you have a strong lock on your front door, if someone leaves the key under the mat, it doesn't really matter, right?
That's a good point. So session management is about making sure that those keys, those session tokens, are protected.
You got it. We need to make sure that sessions time out appropriately, that cookies are secure, and that we have mechanisms to detect suspicious activity, like multiple login attempts from different locations.
Okay, this is all starting to make sense. So we've covered input validation, SQL injection, authentication, and session management.
Mm.
What's next on our secure coding checklist?
So we've talked about protecting our applications from attackers, like building those walls and moats.
Right, keeping those bad guys out. But what about establishing trust with the good guys? How do users know that the software they're downloading is actually safe and hasn't been tampered with?
That's a great point. It's like you might have a really strong lock on your door, but what if someone swapped it out with a fake one?
Exactly. So how do we prevent that? How do we build that trust?
Well, that's where code signing comes in. It's kind of like a digital seal of approval.
A seal of approval. Okay, I'm intrigued. Tell me more.
Think of it like a digital signature for code. Developers use a digital certificate issued by a trusted certificate authority to sign their code. This certificate is like a digital ID card vouching for the developer's identity.
Ah, so it's kind of like when you see those verified check marks on social media profiles.
Exactly. It's a way to verify that the code really came from the source it claims to be from and that it hasn't been modified along the way.
Okay, so when I download a piece of software, my operating system can check this digital signature and be like, yep, this is legit.
You got it. It adds that extra layer of trust that's so important in today's world, where malware can be disguised as pretty much anything.
Right, because you never know what might be lurking out there in the digital shadows. Okay, so we've talked a lot about secure coding for applications, but what about the data itself? I mean, where does it all live?
You're talking about the database, the heart of many systems, and often the most valuable target for attackers.
Right, because that's where all the juicy information is stored.
Mhm.
The crown jewels, so to speak.
Exactly. So we need to make sure that those crown jewels are well protected. And one of the most important ways to do that is through encryption.
Oh yeah, encryption. That's like putting those crown jewels in a vault with multiple locks, right?
Exactly. Encrypting sensitive data at rest in the database is crucial. Even if an attacker manages to get their hands on the database files, they won't be able to access the data without the encryption keys.
Okay, so encryption is like that first line of defense for the database. What else can developers do to make sure those databases are locked down tight?
Well, another important principle is database normalization. This is all about structuring the database in a way that minimizes redundancy and improves data integrity.
Normalization. I've heard that term before, but I'll admit it always sounded a bit intimidating.
It can be, but the core concept is pretty simple. Think of it like organizing your files. Instead of having the same information scattered across multiple files, you consolidate it into a logical structure where each piece of data has its designated place.
Ah, so less duplication and more efficiency. But how does that actually improve security?
Well, redundancy can actually create inconsistencies and vulnerabilities. If the same information is stored in multiple places, and one of those places gets updated but the others don't, you have a data integrity problem, and that can lead to all sorts of issues, including security exploits.
Okay, so normalization is about making sure that everyone is working from the same consistent set of data. But how do developers actually achieve this normalization? I know there are different normal forms, right?
You got it. Normal forms are like levels of organization. Each normal form builds on the previous one, adding rules to further refine the structure and minimize redundancy.
So it's like starting with a basic level of organization and then getting more and more refined as you go.
Precisely. For example, the first normal form is about eliminating repeating groups of data within a table.
So instead of having multiple columns for, say, different phone numbers, you'd create a separate table for phone numbers and link it to the main table.
Exactly. And the second normal form builds on that by ensuring that non-key attributes are fully dependent on the entire primary key. It can get a bit technical, but the main idea is to eliminate partial dependencies that can create data anomalies.
Okay, I see the logic here. It's all about creating a clean, logical structure that reduces the potential for errors and inconsistencies.
That's a great way to summarize it. And while you don't need to become a database guru for the CCST exam, understanding the basics of normalization is definitely important.
Got it. So we've talked about encryption and normalization. Any other database security tips that developers should keep in mind?
Oh, absolutely. One that's often overlooked is obfuscation and camouflage. Don't make it obvious what your database contains.
What do you mean?
Well, for example, when you're naming your tables and columns, don't use names that reveal sensitive information.
Ah, so instead of calling a table customer credit card info, you might call it something more generic like Project X data.
Exactly. A little bit of mystery can go a long way in deterring attackers.
That's a good point. But what about the people who actually have access to the database? I mean, database administrators have a lot of power, right? How do we make sure they're not misusing that power?
You're right. Database administrators are like the guardians of the data. And with great power comes great responsibility. It's crucial to monitor their activity very carefully.
So how do we do that? Do we have to watch over their shoulders all the time?
Well, not exactly. That's where database activity monitoring, or DAM, comes in.
Damn. So that's like having a security camera specifically for the database.
That's a good analogy. It tracks all the actions that database administrators are taking, logs everything, and can alert security teams if there's any suspicious activity.
So if someone tries to access data they shouldn't be looking at or makes unauthorized changes?
Exactly. It's all about having that audit trail. And you can also restrict what actions certain users can perform using things like role-based access control. This ensures that people only have access to the data and functionality they need to do their jobs.
Okay, so it's about limiting the potential for damage, even if someone with privileged access goes rogue.
Precisely. And remember those stored procedures we discussed earlier. They play an important role in database security as well.
Right. We talked about them in the context of preventing SQL injection.
Yeah.
But they have other security benefits for databases too.
They do. By using stored procedures, you can control how data is accessed and modified. You can define specific actions that users can perform, limiting their ability to execute arbitrary SQL queries that might compromise data integrity or security.
So it's kind of like giving users a set of pre-approved actions they can take within the database.
That's a great way to put it. Stored procedures are a powerful tool for database security.
Okay, so we've covered a lot of ground on database security today. From encryption and normalization to access controls and stored procedures, this is a lot to take in.
You know, we've spent a lot of time talking about all the things that can go wrong, right? All the ways attackers can try to break into our systems and wreak havoc.
Right. Input validation, SQL injection, all those scary things. It can get a bit, well, overwhelming sometimes.
Oh, for sure. But here's the thing. Even if you do everything right, even if you build the most secure system imaginable, errors can still happen.
Because no code is perfect.
Exactly.
Yeah.
Software is complex, and there will always be unexpected situations, unforeseen circumstances, things you just can't predict.
So what do we do? I mean, how do we deal with that? Do we just throw up our hands and say, well, I guess we're doomed?
No, not at all. That's where error and exception handling come in. They're kind of like the safety nets of our coding world.
Safety nets. Okay, I like that analogy. So it's
Mm,
about making sure that even if something unexpected happens, the application doesn't just crash and burn.
you got it. Instead of a catastrophic meltdown, we want to handle those errors gracefully, maybe display a helpful message to the user, log the event for later analysis, or take some other corrective action.
Right, because a good application shouldn't just fall apart at the first sign of trouble.
Exactly. It's about resilience, and it's also about security.
Oh, right. Because if an application crashes, it could potentially expose sensitive information or create vulnerabilities that attackers could exploit.
Precisely. So error handling isn't just about making our applications more user-friendly, it's also a critical aspect of security.
That makes a lot of sense.
Yeah.
So how do we actually implement error and exception handling? I mean, what are some of the key concepts developers need to understand?
Well, different programming languages have different mechanisms, but the basic idea is the same. We want to anticipate potential problems and provide a plan for what to do if those problems occur.
So it's kind of like having a contingency plan for every possible scenario.
You could think of it that way. For example, in Java, you have the try-catch model.
Try catch. That sounds almost self-explanatory.
It is. You basically try to execute a block in code, and if an exception occurs, you catch it and handle it accordingly.
Okay, that makes sense. So it's like having a safety net under a trapeze artist.
Mhm.
Even if they fall, they're not going to crash to the ground.
Exactly. And you can have multiple catch blocks to handle different types of exceptions.
So it's about being prepared for anything. And this is all stuff that's covered on the CCSP exam, right?
Oh, absolutely. Error and exception handling is a key topic for the CCSP.
Well, there you have it, folks. We've covered a lot of ground in this deep dive into secure coding. From input validation and SQL injection to database security and error handling, we've explored some of the most important principles and techniques for building secure and resilient applications.
And remember, this is just the beginning. Security is an ongoing journey, not a destination. There's always more to learn, new threats to address, and new technologies to master.
So true. But hopefully, this deep dive has given you a solid foundation and inspired you to continue exploring the fascinating world of secure coding.
And if you're preparing for the CCSP exam, well, we wish you the best of luck. We're confident that you'll ace it.
Until next time, happy coding, everyone, and stay secure out there.